My name is Nick Eberts. I am a product manager at Google working on fleets. And I'm here with Michael Fornaro. Michael, you want to introduce yourself?
Yeah, hi guys. My name is Michael Fornaro. I'm one of the platform engineers for ANZ, which is an Australian bank.
Yeah, that's awesome. We also have Tim, major contributor to this talk. He's sitting right here. He's going to answer all the questions at the end. All right, so what we're going to go over today, we're going to talk about platform engineering. What is platform engineering and how it's different from DevOps? Maybe, I don't know. And then also ANZ is we're going to talk about their journey towards building an independent platform. We're going to talk about Teams tenancy and how we can help solve that with GKE fleets. And then we're going to dive into the evolution of ANZ's platform, like how they're progressing, what their goals are over the next couple of years. Do a little bit of a deep dive into fungible clusters, do another demo, and have some Q&A if we have time. Sound good? No. Doesn't it sound good? All right, let's go. All right, so platform engineering. Michael, you've heard this term before, surely, but where did it come from? Like, why are we talking about this now?
Yeah, so platform engineering has been around for a few years now. I think it's gaining a lot more popularity. A lot of people out here today probably have heard the term DevOps is dead and all these types of things. And I don't think platform engineering is really there to replace DevOps at all. They actually worked well together. But what platform really is at its crux is it's changing the way you think and you build the platform itself. Thinking of it as a tool, not just a tool, but an actual, I can't think of the word.
Yeah, so one of the things is that we recognize, right, is that when we're on this path to DevOps, it was, oh, hey, ship the org this way. I'm going to co-locate these engineers with the software teams, and that's the way it's going to work. And that works for a lot of people too, but what we're seeing is that, especially with Kubernetes, there's this proliferation of clusters. You've got a lot of infrastructure to manage, and there's a good benefit to centralizing it, right? Especially on the infrastructure bin packing side, but also on the human being toil side. You can build this abstraction and then deliver that to the dev engineers instead of having to kind of ship DevOps across your org of hundreds of business units. So the thing is, platform engineering is kind of like a repurpose of the DevOps philosophy. So DevOps is great, but it's a philosophy, it's a practice, and platform engineering is just one way to sort of implement that with kind of central controls. So I love this model. Shout out to my coworker, Eddie Vialba. He came up with this, and I stole it. So thank you, Eddie, if you're watching. So this kind of model helps you break down the problem, right? On the top, you have these domains that you have to ship and sort of think about building, right? That's the point of the platform. You're going to talk about how you're going to ship code, how you're going to build code, how you're going to deal with tenancies, security, observability. And then on the bottom, you have like cloud providers and a pile of tooling on top of it. The interesting thing here is that the common interaction between these two layers is Git, container images or OCI images, and the Google Kubernetes resource model, right? And so the power of having those common abstractions really helps you have flexibility and choice over what it is and you're going to build and how you're going to build it. So hopefully this model helps you out when you're reasoning about platforms, but let's go to the next slide. I also want to call out that when you build a platform, you have to figure out who your users are. Maybe in day one, it's your prototypical dev user. I don't know what that means anymore, but maybe that's your first user, right? The beauty of Kubernetes is that as you progress and build that interface and build that abstraction for the dev user, you can then say, oh, wait, hang on. I think LLMs are really cool right now, so maybe we should build an abstraction for an AI/ML data scientist, human person. And you could build it on top of the same infrastructure. So two key things is, one, you can serve multiple personas from the same platform by building interfaces that make sense for them. And then on top of that, don't try to do all of them at once. Don't build a platform for 10 different personas all at once. You will not have a good time and likely fail. Pick one, get a quick win, learn some things, and then start to add the users as you go along.
Yeah, so before we really get into what we've done in ANZ and like how we've been able to deliver our platform, we'll start with like what is it that ANZ has tried to do over the last few years. So ANZX was a division in the bank that had this vision of reimagining how banking would be done. And so what this led to was what eventually became a new digital platform or a new digital offering to its customers, known as ANZ Plus. So this is the new bank that we've been delivering over the last few years, and these are just some of the features that the new digital bank has been able to cater for. Now, historically, a lot of these sort of customer journeys or experiences were very fragmented. We definitely had mobile apps and we had web apps, but a lot of these experiences still meant that customers would have to go to a branch or go see someone physically. And that wasn't what we wanted to achieve with this new digital platform that we're building. So why was it worth us investing the platform team to create ourselves an IDP inside of ANZX? And the reality comes down to this. Every one of those customer experiences or journeys translates to tens, hundreds, or even potentially thousands of different microservices. So if we want to be able to scale and provide the best customer experiences and journeys rapidly at a velocity rate that continues to grow and meet that demand, then we need to be able to have a way to ensure that engineers are focusing on the right things and not having to deal with low-level complexities. And the reality is that this ecosystem that we're building continues to grow. And this is something that engineers in all organizations face. This ability that where they have to create a platform to be able to ensure that your engineers can move without that friction. So how did we do it? Well, first of all, I think it's important to look about where we actually came from. So we definitely didn't get it right the first time. And so about 2 years ago, we started building our platform and we thought we knew what our engineers needed. And so we had regulatory requirements and we had security requirements, and that led to our first instance of production, which eventually led to us going live with our ANZ Plus offering in about 2022. So since then, it's been fantastic. We've had a rock solid production cluster. We haven't really had any massive outages or anything like that. However, thinking of the platform offering as a product to our internal engineers, the feedback was always consistent from the engineers. And that was that it was extremely hard to actually get their software all the way through to production, especially in a financial organization that has so many gates and processes that they have to go through. So we wanted to try and address this friction and really simplify their process. So what that led to was us partnering up with Google engineers. And that's actually last year, that's where I met Nick, and I met some other great engineers in Google. And we tried to reimagine our platform and treat it like a product, rather than just a collection of tools that we throw at engineers and try and get them to figure out those complexities and how to use them. And so we're actually still building it. A lot of the things that I'm going to be able to demo a little bit later are things that we're building and are in flight right now. So this isn't like a perfect thing. We're continuing to evolve. And the key part is we're always looking at changing our engineering culture so that we get early adopters into this new platform. And that way we get these feedback loops very early to make sure we are solving the right problems as a platform team, because we don't want to waste effort if no one's going to adopt it in the end of the day. And I think that's a really good gauge if you're tackling the right problems. So what did we do? Well, at a high level, we've tried to build the platform as an ecosystem of our own internal APIs. So these are contracts that we have between us and our engineers. And so what we're able to do with these APIs is we're able to use these to create really good automation. And we can create clear interfaces using API v3 schemas. And these interfaces are now declarative things that we can store in source control. And engineers are able to self-service, choosing from an array of patterns that we've already pre-approved and have prepared for them out of the box. And it takes away a lot of that complexity. Now, the other part of what we've been able to do in this journey, now that we've got this all declaratively defined, is we're leaning heavily into GitOps. So in our particular case, we're using Flux CD to be able to sync all these manifests into our management clusters, which then our custom-built operators and controllers will then be able to instantiate those things. Now, interesting note, for those that haven't heard of KCC, that's an open source Google tool. It's called Kubernetes Config Connector. And what this allows us to do also is also build our infrastructure and lifecycle manage it with our Kubernetes applications. So this has been a huge thing. Typically, we always were using Terraform, and the lifecycle management was completely fragmented. And I'll touch on a few of those points a bit later. But using things like KCC, where it's a declarative representation of your infrastructure, flows perfectly with this GitOps and creating multiple clusters and fleets of infrastructure, which we'll touch on soon. And obviously the end goal here is that we want to be able to have our engineers self-serviceable, completely autonomous, so that us as platform, we're not in this process. And we get this unified ability where everything that we're doing follows patterns. So rather than having 1,200 different engineers doing their own thing everywhere, and it's the same thing, we can unify that experience and get the same outcome for those engineers. So what does that look like? Well, now that everything's an API, and what Nick just talked about with this platform is there's sort of different ways that you can interact with the platform. So one of the things that we did very early on is a lot of engineers are familiar with Git, they're familiar with CLIs, they love just jumping in their terminal and doing things. So this CLI is a wrapper. So what we can see is happening here is effectively an engineer can request what we call a workspace. And this is a higher level construct, which effectively means they're going to get a GCP project, they're going to get tenancy, they're going to get IAM, they're going to get workload identity federation for keyless authentication for their GitHub workflows. They're going to get all these things out of the box. And all they give us is a little bit of information, and this will spit out all the declarative resources in order to create all that and bootstrap them. So historically, onboarding teams would take somewhere between 3 to 6 months for them to be onboarded and be able to eventually get their code to production, which is just crazy.
It's a long time.
It's a very long time. So with this approach, we've able to speed this up. So requesting a workspace, onboarding new teams, has been reduced down to about 15 minutes. So a massive increase, or decrease, I should say, in that time that we can deliver them.
Yeah.
And in this bottom one, what they're doing here is they're actually defining that they have an intent of using a particular cloud runtime. They want to use Kubernetes, and they want to use Cloud Run. And what this does is this then bootstraps them into a Kubernetes cluster in the right environments that they've defined, and again, gives them the patterns that they need. Now, it's not just a CLI. Ultimately, we did build a UI to drive this. A lot of engineers, maybe they like ClickUp, so they like to just be able to see that visual representation, and that's fine. So they still have a UI to be able to interface with all this as well. And then for those superhero YAML stitches, they can also just directly go and create the manifests. They don't have to use the CLI at all. This is just an easy way to bootstrap the template itself. But Nick, we've got this far. Like, tell us, like, what's Google doing to make a lot of this easier for us as well moving forward?
Yeah, thank you. So Michael's talked a bit about fleets, right? Fleets are organizations of clusters. You can create GKE clusters in other places, and add them to fleets and manage them together. But on top of that, we started to build concepts to help you with tenancy, right? So one of the problems you have right now with Kubernetes or with GKE in general, if you go in the console, actually by show of hands, who's using GKE today? Brad.
Pretty much everyone.
Okay, yeah. So when you go in the console and you look at a cluster, you either have read access to the whole cluster, write access to the whole. It's the RBAC boundaries around the cluster, right? And if you start building a multi-tenant model in which you're slicing that cluster up across multiple teams, you want to be able to give a UI that's restricting those teams only to the namespaces that they belong in, right? So we built this concept of a scope, a team scope, that allows you to create aggregations of namespaces across multiple clusters, bind role-based access controls between those namespaces that get created in the clusters and your groups and users in Google Cloud Identity, and also keep up with adding the clusters that you want to bind to those fleets, or to those scopes rather, so that whenever you bind a cluster to a scope, it automatically creates that namespace in the cluster. So enough talking about it, right? We're here for live demos. This is now the time that you stop using the internet. And so this is familiar, right? You're all using GKE. It may be a little bit less familiar because you could see the enterprise SKU up here. We released this into preview today. I want to drill into the teams flow, right? So I've got teams here. And you can see I've got 2 tenants created, right? I've got the alpha tenant and the Bravo tenant. Now I'm going to go into the alpha tenant. Oops. And you're going to see that I've got I have team 1 group that's bound to it. So this means that there's going to be a role-based access control that gets installed in all of the namespaces and all of the clusters that's bound to this team scope. I've got some monitoring. This is going to improve as the product improves over the next 6 months to GA. And you can see which clusters I've bound this scope to. I have 2 of them, US East and US West. And you can see the namespaces. So you can see that I have demo and new demo. So I have 2 namespaces within this scope that are distributed across all those clusters. Now, if I was good at demos, new demo wouldn't be here right now because I'm supposed to show you creating it. In lieu of that, I'm going to create another demo namespace. So to create a new namespace, I'll add namespaces. We'll call it new demo 2 and update the team scope. And there's Terraform for all of this stuff. Eventually there will be KCC for all of this stuff. So you could do this with infrastructure as code. It's just easier for me to show you the portal. And now I've got a new demo namespace. And if I look at inspect the clusters, you'll see that this namespace is popping up in those clusters. But that's not enough, right? Do we stop at namespaces? Does our job end there? No, we want to actually put some applications in those namespaces. So for now, what that means is you're gonna go out of our flow and go probably into some Git flow somewhere. And we've got a PR all queued up. So I'm gonna merge this pull request, and when I merge this pull request, it's gonna install an application in that namespace, create a HTTP route for a multi-cluster gateway, which allows me to then access that application through a load balancer that's going across multiple clusters in Google Cloud. Let the suspense build. As that's adding, let me show you the route. I think it's interesting. So this HTTP route for new demo. Can you
just also worth mentioning that everything that we're demoing here is like we've open sourced this repo, so we'll send out a link or we'll put a link up later. And
yeah,
if you want to have a look at what we've actually done and probe around and see some of the things, then feel free.
All right, so it's just a where am I app. This app just gets some metadata about the pod and node that it's living on and tells you where it lives. So when you hit it, if you're getting routed to the region that's closest to you, it should report back, say, hey, I'm in a node on US West, here's my IP. And I've appended a value. So one interesting thing here is I'm using multi-cluster gateway. I've got a shared gateway for this team already stood up. I add a new namespace. I don't have to add another load balancer or gateway. What I need to do is just add another route within that tenant or that namespace. So it makes it easy, right? I'm just adding a route. It's going to adjust the rules that are on that load balancer. And within a couple of minutes, I should be able to hit that endpoint. And so I'm using a path prefix, which is weird because it's kind of a suffix, but whatever. And this is the old app. It's that was already there. You can see that it's hitting, where are you?
Over here.
Pod namespaces in demo. That's not the namespace we created. So if I add that suffix as new demo, it is not yet up. Oh, there we go. Sorry. And I'm going to try this 2 more times, and we'll come back to it later if it doesn't route correctly. All right, moving on. If that worked, it would have went to a pod that's in the new namespace that I just created called new demo. We'll come back to that though if we have time, and it will work. It just, GitOps takes time, right? You declare your state, and then you wait. You declare your state, and then what do? Wait!
Yeah, ultimately it is eventual consistency. So what happens after the apply, that's going to go through like a whole heap of orchestration between controllers and operators.
Okay.
There's a lot of moving parts to make all the multi-cluster ingress actually work. So
yeah, and so that concludes the demo. I will prove it to you that it works by the time we leave here, I promise. So moving on, so we talked about your platform journey, right?
Yep.
Like the start of it. But I assume you didn't get it perfect from the get-go. You talked about iterating. So tell me some of the problems that you came up with and the solutions that you had on this journey.
So early on in our platform journey, and even just recently as we're sort of building the platform that we have, there was a number of different things that we were facing as platform operators. Now, these aren't all concerns that necessarily the engineering teams had, but they were certainly like, they're a bit of a mixed case. And this isn't a definitive list, right? There's a whole heap of other things that we've been trying to solve as we've been progressing the platform and trying to evolve that product. So just touching on these really quickly, because I know probably a lot of engineers at some point have hit one or many or all of these issues at some point in time. The first one that we've found really difficult prior to what we're trying to do with fleets and managing the lifecycle of clusters has always been disaster recovery. Now, a lot of people, including ourselves, we definitely have tools that allow us to restore, but if you brick a cluster completely, your best case scenario from that point is probably going to be like just to recreate the cluster, unless you're ready to devote hours and hours to debugging that cluster. And I'll touch a little bit more on that in the future, but in our case, when you recreate a cluster, that's going to change a lot of dynamic or unique values that are between each cluster. So even if you do an etcd dump or you're using like an open source tool that does backups, it's not a trivial task just to copy everything across and hope that applies. It just gives you this beautiful thing that's recreated that cluster. It doesn't simply work. So that's one of the things that we were trying to solve with this. The other thing that then leads to that I've seen is configuration drift. Like you see this all the time. Engineers are playing, and like I'm guilty of this as well. I'm pretty sure I've left a few test namespace clusters. And what this is actually pretty bad practice, because what we have is if we have 1,200 engineers across the ecosystem all playing and manually creating things and backporting it, there's no single source of truth to recreate any of that. And it leads to this like drift where a lot of changes aren't being backported into our source code, which isn't good either. And this is something that like obviously GitOps definitely helps portray this forward. Some of the other things that then cascades onto is unreproducible deployments. I'm pretty sure everyone's probably had that moment where a deployment worked yesterday, nothing's changed, but tomorrow it doesn't work. And you're now trying to figure out what has changed. Is it the pipeline? Maybe someone's changed some of the networking for that thing. And it's extremely frustrating not being able to diagnose what had changed in your deployment, even though nothing seemed to have changed in your pipeline config. Now, that leads to inconsistent environments. I probably won't touch too much on that. It's pretty self-explanatory, but the next thing is like these dangling resources. Because people are not necessarily following best practices or necessarily following GitOps principles, you find that in these traditional push-based models, people very rarely clean up after themselves. So what you get left with is a lot of Kubernetes resources that are just dangling there left. And these are just orphaned resources. Now, there's some really good open source tools to solve this, but when you're using things like GitOps and you're using Argo or Flux or config sync, this just becomes completely eradicated. It's just not a concern anymore. And then obviously the last two are kind of like just funny favorites. We've all had this where you go to production and you hit this manual approval gate. Now you've been writing code or you're deploying some sort of change, and now it goes off to a manager of some sort, and he has to approve the pipeline. The reality is that person probably doesn't actually know anything about the context of that change, and yet he has to be the one to approve it. So I find that really funny, whereas in GitOps, it's sort of different. Everything's being driven now from your source code, and actually what you're doing is you're empowering your engineers. These are the people that you trust to manage and do their own lifecycle management and deployments, which is a bit of a mentality and a cultural shift. And obviously, some of the things that you get with just traditional push-based models, in this case, this is pretty specific to GitOps, but you end up always having some disparity between your non-prod or your not production and your production pipelines. Now, there's always going to be something. Either it's configuration or it's networking or it's firewall rules, proxy, like it could be a number of things. And so it decreases your confidence when going to production. And that's not something we want engineers to face. We don't want them to have low confidence in you or in their own pipelines. So what does it look like after we're using GitOps, we're using KCC, and we're using sort of this X ecosystem, this interface or abstraction that we've built? Well, a day zero experience looks something like this. An engineer could use the UI to create their workspace. They could also just use the CLI with Git. And in these cases, they give that high-level intent of what they want to use based on the patterns that we've predefined. And we'll automatically, once it hits this repository, it's syncing to our cluster. Our operators and controllers are now instantiating those things. And we're creating their entire workspace of things, as I mentioned before. Day two looks something like this. Engineers now, they interface with their repository. We're not just throwing at them tools unnecessarily and saying, here, you've got 5 different UIs to debug and troubleshoot your tool. They deploy to their repository. We have a GitOps workflow, and at all of these points through the flow, we have feedback loops. And in those feedback loops, we give them deep links to the relevant tools that they can look at to troubleshoot and debug their application. Because we are rendering their Kubernetes resources for them, because we don't want them to have to deal with that low-level complexity, we know exactly what's the environment, the cluster, the application, the namespace, and all these things. We can give them predefined search queries in Google Cloud Monitoring, for example. We can give them other deep links to other insight tools. And so rather than trailing through a CD pipeline, wondering why is my application not deployed, Well, now it's very intuitive. They can actually be directed to where to find their application is failing and why it's failing. And so this is a much better experience for our engineers. And behind all of this, obviously, I'll get to that next, actually. That's fine. So there's a lot of benefits to this, right? It kind of feels like a sales pitch, me saying all this, but ultimately, I can tell you that we've seen a lot of benefits. And in a highly regulated industry like a bank, you know, we have a duty to be secure and resilient and to build our applications with stability. So by doing this, we've increased all those things exponentially. And on the other side of the personas, as Nick was talking about earlier, the engineering experience has increased and has become much better. And we're getting a lot of positive feedback. And engineers are enjoying the ability to have that autonomy and that trust. So enough about this. We're going to talk about fungible clusters and fleets of clusters. So I'm going to let Nick introduce what fungible clusters are. It's probably a term you haven't really heard of. So I'm going to pass it to Nick.
Yeah. So funny word, fungible, right? I don't know why we chose that, but it's the word that we're using. The idea here is that the clusters really don't have personalities. Think of it as like 10 years ago, VMs became, you didn't want pets, right? You were getting cattle, poor cattle. Anyway, same thing is applied to clusters, right? You don't really want to have special clusters that are long-lived necessarily. You want to have shapes of clusters. So what do? You define a shape of a cluster. Now with GKE, that means you define your fleet config and you define how you want to use the networking things I talked about earlier and how you want to set up your config syncs or your Flux or Argo CD syncs, such that when I add a cluster to the fleet, all I do is pass in a label, right? That label's bound to something that understands how to apply all the right configuration to that cluster. And then you just wait, like my failing demo earlier, which works, by the way. I'm going to show you at the end. Anyway, so the idea of a fungible cluster is that you're pre-baking, doing all the work on day 0, adding a cluster with intent, and that cluster is coming up to state. You can go to the next one. And so like at day 1, cluster comes on board. I'm using multi-cluster gateway or multi-cluster ingress, so my applications get IPs, everything's routed. I've got Anthos service mesh or managed Istio, essentially, that's stretching networking across multiple clusters, so I have failover between clusters and cross-cluster service discovery. But like, what's next? The business comes to you and they're like, listen, there's been an increase in latency that we really can't bear for our end users, right? And the SREs have figured out, oh, hang on, this is like, we've actually see that this is coming from a section of customers that are not really close to the clusters that you have right now. In fact, they're all on the East Coast or something, where I live. I am my own user. And so you add this cluster to this new region with the correct label, right? The only thing different is that it's getting put in a different region. It comes up to state. It starts serving endpoints up that get added to the load balancer automatically, and within an amount of minutes, small n, depending on how many applications you have to stand up, it's getting hit with traffic, and you've all of a sudden increased not only high availability, but reduced latency in the process. And it's not too costly because if you have cluster autoscaling and horizontal pod autoscaling set up, the load is going to rebalance itself based on the requests that are coming in. So you're not really paying a lot more to get that value, right? So that's the idea of fungible clusters. And better than hear me talk about it, Michael's going to show you a demo in which he walks through this.
Yeah,
recorded, but
yeah, this is pre-recorded. Now, the reason I've pre-recorded this is because you don't want to sit there and just wait for a cluster to come online. That could be a bit boring, but I'll show you everything leading up to it and like cut a section out with the magic of, editing, and then you can see what happens at the end. All right, so this is going to be a demo in using GitOps with KCC and creating infrastructure in a way that scales so that you don't have to add that complexity onto your users. So what you can see here is I'm actually showing that scenario that Nick just went through. We've got a management cluster, that's cluster 01. And we have this other regional cluster. This is the one that's actually hosting our applications. The management cluster here is purely just for your platform operators. Your customers never have to see that. And so I'm just hitting at a test application. This is the one that we've already deployed. That's the Where Am I application. You can see it's in US East 1. So obviously we want to spin up traffic that's closer for us Australians. So we want something in maybe US West 1. So what we can see over here is, this is the configuration that I've stored declarative in my repository. Now, there's a bit of a hack script here. This is just to create the management cluster, so don't be alarmed by this. There's a bit of a chicken and egg like inception thing where you need a cluster to create more clusters. So this handles creating that initial cluster. And that's just your management cluster. The Kubernetes folder up here, there's 3 folders. There's clusters. Now that's simply a folder that Flux uses to lifecycle manage itself and to register the clusters. Then there's namespaces. Now this is all customized. So if you're familiar with customized, you'll understand this a little bit. But this is just where we're creating namespaces for platform components and where we're deploying the platform tooling. We don't really want tenants to necessarily have to see this. This is all the stuff behind the scenes. And then when we onboard tenants, we actually have our tenants are declaratively defined in this bottom folder. And what that does is that all happens as part of their bootstrap when we onboard a team, and that they tell us they want to use Kubernetes as their cloud runtime. So we create them a Flux tenancy, which then allows like Team A not to deploy to Team B's things. They have that like isolation because we are using multi-tenant clusters, like these are multi-tenant clusters. So we've tried to simulate that here as well. And so you can see like they've defined their application here in the app repo. This is just a typical Flux resource. They're using Helm. It could be customized, could be Helm, could be anything else. In this case, it's a Helm chart. So they've defined their Helm chart. And this is what they want to deploy. Now, the interesting thing to note here while we're creating this cluster, I'm just going to probably, so I'm actually just going to show you the applications, show you how it's deployed, so we all know that there is replicas. But while we're looking at this, the interesting thing to note here is the application team never have to define all of the clusters in production. They just define that they want their application in production. So when we're talking about fleets of clusters, that complexity of 1 or 500, they should not have to be contextually aware of that complexity at all. So that this application can scale across the fleets, and they only have to know about their application in one cluster. They don't have to think about how many are behind the scenes. So in this case, where am I up to? So I'm just showing you the multi-cluster ingress and the multi-cluster service resources. Now, these are all Kubernetes resources, so we can define them and store them in our repository and have them also GitOps, which is awesome. And over here, you can see that the multi-cluster ingress object is recognizing that I have a service that is in this cluster. It's creating the negs for me automatically and setting that up to a global load balancer. So this is like handling that split of traffic that Nick was talking about earlier that we want to already have. But we want to have this automatically happen when we add clusters. We don't want to manually be configuring all this. And this is sort of the beauty of multi-cluster ingress or multi-cluster gateway if you want to use API gateway or gateway API. So that's fantastic. So when we want to add a second cluster, now I've just stitched this together and I've copied it myself. Realistically, you'd probably have some sort of template or some sort of engine or thing that spits this out. Internally, we have our own tooling that would do that. But for the sake of the demo, I haven't actually ported all that over here. So you can imagine this is all pre-generated stuff when you want to add a cluster. It's all just cookie cutter stuff. It's a cluster without a personality. It's just another 0-2 cluster. It doesn't have a special name. We just know that this is another identical cluster of production, except it's going to be activating in a new region for us. So this is what we're going to deploy. Now, in this case, when we deploy a new cluster, I don't really want to have all these manual steps of like bootstrapping Flux and then deploying all these tools and all these things. So what I was just showing there with that alert is that Flux is able to automatically trigger a workflow that uses workload identity federation, which gives us keyless authentication back to our GCP projects so that it can dynamically bootstrap not only Flux, but everything that Flux then cascades and knows about. So it automatically gives all of our platform tooling into this cluster, and then subsequently, after that's successful, it'll automatically deploy all of our tenants and their components. And I haven't had to add any other configuration. I've literally just said, give me another cluster, and that all happens, which is good. So in this case, I'm just showing those sort of bindings to make workload identity federation work with GitHub. So that's something really cool that we use. We do use GitHub workflows. There are scenarios and use cases for that. So not everything can just be magically done by GitOps. You got to pick and choose what you need to use when you need to use it. But in this case, this is the thing that's actually giving us that workload identity federation. And this is a KCC resource. So you can do it via Terraform, or you can have it done via GitOps and do it with config connector. So where I'm up to right now is I'm just going to merge that pull request. At least I know mine will work because it's recorded, whereas Nick's didn't work. Sorry, Nick.
It works now.
Yep. Well, so similar to Nick's, it does take time. So you can speed this up with, creating much more fine-grained or reduce the intervals at which you're reconciling. You can do things like put a webhook receiver in here so it speeds up. GitHub will actually push the event and trigger a Flux event to sync. So you can do things to speed this process up. For the sake of the demo, we didn't go that extreme. So you can see over here, I am looking over here and I've actually seen that the new cluster, well, we're waiting for, so we've got cluster 0 that's here. We're waiting for Flux to update, to sync and apply that config. And then what we should see is a new cluster. We should see cluster 02 come here. And all I'm doing is sort of just showing you what it looks like if you were looking at it through the terminal. You don't have to do this. You can just like walk away, come back with your coffee and things will be done. But in this case, we can see the cluster 02 came up. It did take about 8 minutes. So there's a bit of magic editing there. But now we have a cluster 02. Now what happens after the cluster's ready? Well, like I said, we still need to put everything onto the cluster. It's just a bare bones cluster at this point. So through that alert that we configured earlier, it's now automatically triggering a workflow. And this workflow will then do everything that I need to dynamically for me. And it's automatically detecting that metadata of that cluster. So the things like the cluster name and anything unique or dynamic, it's able to figure those out based on the alert we provided. And it's using that payload to then do what it needs here. And so now we're just going to change our kube context so we can locally see it in the terminal. And what we should be able to see is all those components now coming up. And still, we haven't actually done anything. Now, why is this important? Because if you're handling fleets of clusters, tens to hundreds of clusters, and you're trying to scale your fleet of clusters, you can't be managing this in the traditional sense where you have to go trigger 500 different pipelines that might be in different teams and different repos. It's just not going to work. And that's why one of the advantages here for us of using GitOps with our API-driven platform has been so advantageous here. So what we're seeing here is everything's starting to come up. The Where Am I application is starting to sync. Now, it didn't come up immediately. I was a bit impatient. We are showing this using autopilot. So this is sort of like the hybrid between GKE standard and maybe Cloud Run, sort of that sort of serverless experience. So it does take a few seconds for the compute to spin up to our needs. But in this case, as you see, I did it again. The namespace now exists and things are slowly coming up for us. And what I'm checking here is that the multi-cluster ingress is running. And we're pretty much going to see this all automatically create new negs to the load balancer that was already created. And then we'll be able to hit the application and hopefully we'll be able to hit it on the terminal. And what we're actually going to try is hit that application now live. So I think we're going to skip to you, Nick.
Sure. We're using this now. Come on. Is yours working?
Yeah, so there's some extra stuff. You can ignore that, but this is just good stuff to see if you want to look through the UI. There's all this information that GCP will provide you when you want to look and manage your fleets. So you can feel free to go through that on your own accord. It's just something good to see.
All right. There we go. So can we go to my laptop one more time, please? Sorry. We there? Okay. So this is the endpoint that he was hitting earlier that was going to US East, and now you can see it's going to West. And I'm hitting it repeatedly. I just got to say, man, I didn't do anything for this demo. I really appreciate that you did that. And I'm going to slow clap until everyone joins. Yeah. All right.
Took me a couple of days to hack that.
Quickly, because I will never hear the end of this. Look, see, it's working. It's going to the new demo. Okay. All right.
Well done, Nick. Well done.
Yeah. Okay. We can go back to the slide now, please. All right. So yeah.
Yeah. So look, there's other benefits to running fungible clusters. I won't go through all this list, but when you think of your clusters as more immutable resources, and when you start to lifecycle them in that way, I would say In our case, we've tried to treat our worst case as our best case scenario. So what I mean by that is, if you're going to brick the cluster and you have to recreate it, that's what we're going to actually do as many times as possible and get really confident and really good at recreating clusters. And so in our case, that's what we're striving to do. And what that does is that exposes all of the toil and friction in that process. So when it actually does occur, your engineers know what needs to be done. And before that's even occurred, you've already safeguarded yourself and fixed a lot of the tech debt that you might have faced. Lots of other reasons why you might think about using clusters in this way and using fleets of clusters. Feel free to check this out in your own time. I'll hand it over to Nick to give us some final wrap up.
Yeah, so we're at the end. Just some quick closing thoughts. One, please, if you're going to build a platform, treat it like a product, okay? It's not a one-time thing. You don't just build it and walk away. It's got a life. Also, check out fungible clusters. It's going to be a little pain up front, maybe a little more than a little pain up front, but your life will be easier for it in the future. Fleet tenancy is GA today. So the fleet team stuff, RBAC and namespaces, all GA today. Engineers are in the front. Well done to them. And then, yeah, if you want to talk about it, reach out to me or any of my team. We're happy to tell you about it and get you like a roadmap session where we really get the rubber hitting the road.